Hi, and so moving ever onwards with our trigonometry, we're going to have a look at how we can express trig ratios as exact values. There's a couple of kind of sneaky little tricks along the way that, if you're familiar with them, it just kind of really helps you out when you're dealing with the more tough stuff, particularly next year. So here we go. So we're going to express sine, cos, tan of angles, and we're going to give them as exact values. So we're going to be using square roots along the way here. So off we go. First lot are to do with specific angles. So if I take an isosceles right angled triangle like that, so we've got obviously right angled triangle, each side 1 unit, and those two angles clearly it's isosceles, so those have got to be 45, and we know from using Pythagoras that the hypotenuse is the square root of 2. What that means is if we've got all those three sides, we can now work out sine, cos, tan of 45 very easily just from the lengths of the sides. So we've got sine 45 is going to be opposite over adjacent, which is 1 over root 2, and you've got that form there, root 2 over 2, which you just get from times the top and bottom by root 2, rationalise the denominator, so we've got sine 45 is root 2 over 2. Cos 45, adjacent over hypotenuse, so 1 over root 2 again, so it turns out cos 45 is going to be exactly the same, and tan 45, opposite over adjacent, so tan 45 very simply just has a value of 1. Okay, so what we've got there is sine, cos, tan of 45, all written in terms of, well, particularly with sine and cos in terms of roots, tan 45 is 1. The other standard angles you need to know come from this triangle. And what we're going to do with this one is take an equilateral triangle, it's side length 2. I'm going to just say, well, as we know, those angles are 60 degrees. I'm going to just drop a line down the middle. There we go. So now I've got a 30-degree angle, and we can see in this right angled triangle here, this base side now is just 1 unit. So what we're going to do is work out sine, cos and tan of 60 and 30. To be able to do that, I need to work out the height, and again clearly a little bit of trigonometry, a little bit of Pythagoras tells us that the height is going to be square root of 3. Now that we've got all that, we can say, well, sine 30 is my angle up here, sine 30 is going to be 1 over 2, so sine 30 is a half. Cos of 30, there it is, cos of 30, so we need now root 3, the adjacent side, over 2, so cos of 30 is root 3 over 2, and the tan of 30, opposite over adjacent, 1 over root 3, which becomes root 3 over 3. So those are our exact values for sine, cos, tan of 30. Now if we do exactly the same with 60, so we've got sine 60, and again, hopefully we can see that sine 60 opposite over hypotenuse. So that's going to be root 3 over 2, same as cos 30, because remember we had that sine 90 minus x equals cos x, and vice versa, because of the way those two things are linked together. That gives us cos x, clearly how spotted now that that's going to be a half, and tan of x, sorry, what I'm saying, tan of x, tan of 60 degrees being here. There we go, so we've got root 3 over 1, so the tan of 60 is simply root 3. Now, those values, clearly you can get them off your calculator. You've got your calculator in the exams, but it is genuinely really, really useful to be able to recognise those particular values, because they do pop up again and again and again. So you don't necessarily have to know exactly what it is, but as long as you recognise that root 3 over 2, you know it's going to be a sine of 60 or cos of 30 or whatever it's going to be, then you can figure it out, and it makes life a whole lot easier later on in a range of different ways. So that's those. The other type of question we're going to look at is these. So we've got, we're told the tan of an angle has a value of 2, and we know, or we're told that angle is between 180 and 360. So given that the tan of the angle is 2, what is the exact value of the sine of the angle? The key thing to understand here is at no point are we being asked for an angle. I don't actually care what the angle is, because I need to work out the sine of the angle. So we've got tan theta equals 2. Now tan theta, if I write that as a fraction, that's just 2 over 1. And so, well, I know that tan theta is opposite over adjacent. So what I can now do is imagine this as a triangle. So I'm going to take a triangle and draw it in the third quadrant, because what we're saying is this value here is 0. As I go around, 90, 180, 270, 360. So if I want theta between 180 and 360, it's going to be in there. Now, why has it got to be in the third quadrant? Well, the reason for that is if this value here is positive, we've got a negative side there, a negative side there, so those negative divided negative makes a positive. If it had been in the fourth quadrant, what we would have found would have been the opposite side still would have been negative, but this side, the adjacent side, would have been positive. So tan in the fourth quadrant would actually be a negative value. And we're not told it's not a negative value, we're told it's positive, so that means it's got to be somewhere between 180 and 270. So we've got that. What we've got to do now is take this triangle and figure out, well, we need sine, so we need the hypotenuse. So a bit of Pythagoras will give us that value there is root 5. And so now we can say that for that particular angle, that value of theta, we know that sine theta is going to be minus 2 over root 5. Rationalise the denominator, and we've got minus 2 root 5 over 5. So there we go. So there's the exact value for sine theta. Again, I didn't work out what the angle was. I just used the information given, drew myself a little sketch of a triangle, and away we go. We've solved our problem. On we go. Part B. We've got, we're told cos alpha, alpha being an angle. We tend to use a whole range of Greek letters to indicate angles for whatever reason. But we're told that cos alpha is minus 8 over 17. We're told that alpha is obtuse. So straight away, if it's obtuse, we know we're going to be in the second quadrant between 90 and 180. So there's my triangle. So again, this time it's the adjacent side is minus 8. The 17 represents the hypotenuse because cos is adjacent over hypotenuse. And again, if you recognise your Pythagorean triples, you'll recognise that that means the missing side here is 15, because that's kind of the 8, 15, 17 triangle. Obviously, if you didn't recognise it as a Pythagorean triple, don't worry, you've got your calculator. A little bit of calculating will give you the value. But you often find that Pythagorean triples 3, 4, 5 appears quite a lot, 5, 12, 13 appears quite a lot in these kind of questions. So there's our triangle. We're being asked for the value of tan alpha. So tan is, as we know, adjacent, try again, opposite over adjacent. So tan alpha, there we go, minus 15 over 8.